Hi, I'm Randall Heyman, a mathematics academic, and you're on one of my Corona Help playlists where I make quick turnaround videos to help educators and students. So if you'd like me to make a video for you, then you can either comment me below any of my videos or drop me an email. So this is for Megan. Let's write that up there. I'm not sure what country Megan's from, but she asked for help with a problem on the Chinese remainder theorem. She had a look at my video and is still a little bit confused. It's actually my biggest video out of them all. I think it's had something like 350,000 views or something like that. Anyway, let's see if we can have a go with this. Okay, so the first thing to say here, Megan, is if you're going to solve this using the Chinese remainder theorem, then you need to first check. So let's go to blue. So one, check that the GCD, the greatest common divisor, 5 and 11 equals 1. And there we can, that's fine. The GCD is 1. Now, the Chinese remainder theorem tells us that there is a unique solution for n modulo 5 times 11. So, i.e. n, so there's a unique solution for n modulo 55. Okay. Now, the Chinese remainder theorem doesn't actually tell you, the theorem doesn't tell you how to find the solution. The proof of the Chinese remainder theorem does tell you how to solve it, if it's the normal constructive proof. So if you want to annoy your lecturer or tutor or whatever, if I say solve this using the Chinese remainder theorem, you say, well, you actually need the proof of the Chinese remainder theorem. Okay, so now, the first thing I'll just address is if no requirement to use the Chinese remainder theorem, so it might just sort of say solve for n. Well, then you can use trial and error, which for this sort of problem is actually not that hard. For example, here I could just start, you could just start reeling off all of these n's. What could n be? Well, n could equal 3, then 3 plus 5 is 8, 8 plus 5 is 13, 18, etc. And then I could also do n here using this one. So here, this is the mod 5, mod 11. So it could be 7. If I'm just applying mod 11, then 18. And once we get to 18, we can see here we've got 18 and here we've got 18. So n is equivalent to 18 modulo 55. So that's an answer, that's a solution. Now, the other way that you can do it without the Chinese remainder theorem, trial and error. So that's how we would do trial and error. Or there is another way that you can do it where you go, let me just see the numbers up here. You can say n is equivalent to 3 modulo 5. 3 modulo 5. So that implies that n equals 5s plus 3 for some s. Some s. And n is equivalent to 7 mod 11. Implies that n equals 11t plus 7 for some t. And so we can equate these two. So 5s plus 3 equals 11t plus 7. and then etc. I'm not going to go through how you would do that. So that's the second method that you could use. But okay, let's now assume that you're definitely going to use the so if told, you must use CRT. And the CRT is really the best way to do it if the numbers are very large. Here the numbers are very small, so trial and error works. But otherwise, this method here will work for large numbers. So okay, so off we go. Let's do this. So I'll just write up here just so I can see once again 3 mod 5 and n is equivalent to 7 mod 11. I've got to slow down my writing. I'm writing so badly. The more of these videos I do, the worse my writing seems to get. What was that? That was mod 5. Okay. So the way I say it in the video, I explain it is, well, we know that firstly the answer is mod 55. That's useful. But then what I'm saying is, what we can do is we can create this addition, this big addition. And what we'll do here is, now can I get a pencil here? I want something that's in a nice grey. Here we go, black. Well, yeah, let's write this in grey up here. Okay, so what I'm going to do is I'm going to call this side of the plus sign, this is the mod 5 side, and this side over here is the mod 11 side. Okay, so let's get a black pen up. Okay, or blue pen actually. So let's go to the blue pen. Okay, so this is what we can do is I'm going to put here 11. If I put 11 here times, and I'm going to fill in a number later with a green. I'll put the green question mark, and over here I'm going to put 5 times, and I'm going to use a red question mark. Now let's have a think about this. Let's go here. If we apply this number, once we've worked out the question marks, if we apply mod 5, so if we apply mod 5, then because we've got here 5 times, this whole thing is everything here is going to go to 0. So what we'll end up with is n equals 11 times the question mark, the green question mark, mod 5. I'll rewrite this in a sec. And similarly, if we applied n modulo 11 to this, well, all of this would drop away, and all we're left with is n equals 5 times the question mark mod 11. So what I've done by setting it up this way is I can work out the question marks. Whatever this question mark here, it's not going to make any difference when I apply modulo 11 because, modulo 5, because I've got this 5 here. So let's just now flesh that out. Okay, so how are we going to do that? So let's move this up a little bit so we can still see what we need. Let's go to blue. So let's apply modulo, let's do modulo 11 first. So what we'll have is n is equivalent to, this bit will drop out here. That'll go to 0 because I've got that 11 there. Okay, so that is 0. So I'll actually write it this way, just so you can follow. 0 plus 5 times, we're going to put this in a sec. We don't know what this is, modulo 11. And so that's equivalent to 5 times that modulo 11. Now, if we go back to here and look up here, what does that tell us? That tells us that we want 7. Okay. So we want n equivalent to 7 modulo 11. So if you look at this one and this one, what does it mean? So let's find a question mark so that 5 times the question mark is equivalent to 7. So I hope you can see that here. If I can work out what this should be, when I put it in up here and we hit it with mod 11, well, this is going to disappear and we'll have exactly what we want. 5 times whatever this red question mark in will equal 7, which is what we want. Okay, so let's just rub out a few of my little markings and let's keep going. So how are we going to do this? Well, you could just do trial and error now. So you just keep trying numbers for the question mark until you find what you need. And what you'll find is that 5 times 8 equals 40, which is equivalent to 7 mod 11, because 3 11s are 33. So what I'm saying is, so I know now that that is equal to 8. Now, if the numbers, if it's very big and you can't use trial and error, if can't, or you don't want to, can't use trial and error, then find the inverse of 5 and then multiply 5 by the inverse by 7. So what I'm saying is, look, have a look at my video if you don't need it in this case, but have a look at my video if you're interested in that. I think if you just focus on that bit now, if you understand the rest, it'll become clear. Okay, so we know what that is. Now let's do the same thing for green. So let's now apply modulo 5. So if we go back up here, this will all drop away. So we get n is equivalent to 11 times the green question mark plus 0, because this bit here is going to be 0 when we apply modulo 5. And so that's just equivalent to 11 times that. And then we can put modulo 5. So remember, in this crazy world of modulo 5, we can just apply modulo to that to make it simpler if you want. So n is equivalent to what's 11 modulo 5? That's just 1 times the question mark modulo 5. Oh, actually, I should write it like this way, shouldn't I? Sorry, I should probably, I'm giving you bad habits here. This should be bracket mod 5. And this one should be bracket mod 5. Okay, so we want, what did we want? We want n to be equivalent to 3 mod 5, wasn't it? Yeah, 3 mod 5. So I'm just going to let that equal 3. Okay. So, okay, so putting the question marks into, let's call it asterisk, which I'll now go back and label this asterisk. So I'm just going to, now what I'm just going to do is I'm just going to put this in. Let's see what happens. So 11 times the green, so n is equivalent to, what did I say? 11 times, yeah, 11 times the green. 11 times the green was 3, green question mark, plus then I'm going to have up the top here 5 times the red one, 5 times the red question mark, 5 times the red question mark up here, I've got here, actually I'll just drop it so you can see, is 8. 8 modulo 55, because that was 5 times 11. And now we can just sort all that out. 33 plus 40, and that's equivalent to 73. 73 mod 55, and that's equivalent to 18 modulo 55. And finally, you might just want to check, does it work? Check. After you've done all this good work, you might as well check if it works. Well, 18 mod, we said 5. When we apply 5, it has to equal 3. That's true. And the other one was 18 mod 11 is equal to 7. That's true as well. So it looks like, I can put the big green tick here, that is the correct answer. So Megan, I hope that's helped you. If you've got any questions, any more questions on this or any aspect of mathematics, comment me below any of my videos or drop me an email. And if I think I can help, I will.